Now the setup is ready, so whenever you feel ready, you can start.
All right. Should be able to see my screen, right?
Yes, we are able to see it right now. It's
Okay. Let's get started. So, our project is the Kaupang DEX. I'll keep my presentation really short and to the point. So let's get started. So, first thing I want to do is just to recap the things that we have delivered during the previous checkpoint, which was called the midpoint. So, the things that we delivered previously were the following. So we built a wallet as part of our DEX. Since our DEX is based on a custom L2 build and product kit, we also needed a custom wallet integration, including a custom wallet UI. That also included being able to do transfers between different users as part of the UI and the L2. It was followed by XYK style trading pools. So you probably know that as Uniswap V2. So we built something very, very similar to that. Included, creating pools, adding or removing liquidity, trading, and also routed atomic trades. So if there wasn't a pair available to trade directly as you wanted, so the pool didn't exist, you were able to trade across multiple different pools atomically. The last feature we delivered during the midpoint was from our governance milestone, and we built a runtime module or a smart contract that allowed you to vote on to whom the mina that is bridged to the L2 is going to be delegated to. So pretty important feature. So moving on to the endpoint milestones, or what did we deliver since the midpoint up until now? We've delivered the following things. So the first thing is a new kind of a pool. So this time it's not an XYK pool, but it's an LBP pool. It's a new pool type used for bootstrapping of liquidity for XYK pools. One of the features that we could highlight here is that it allows for fair distribution of the tokens and also for like a good price discovery mechanism. Then the second feature we worked on were oracles, more concretely volume oracles. This includes protocol level tracking of trade volume per asset in a given pool, which then enables us to do some interesting features. One of these interesting features is dynamic trade fees, which is the next milestone that we have delivered. What this basically means is that thanks to the protocol oracles, we are able to dynamically adjust the percentage fee that is deducted from your trade when you interact with the XYK pool. It's important that these fees are dynamic so that we can protect the liquidity providers from like price movements that they possibly wouldn't like. And then the very last feature that we have done is multi-asset transaction fee payment. So normally, if you are, let's say, on Ethereum, you have to pay the transaction fees in ETH, right? This makes onboarding to DeFi pretty cumbersome. And the way we try to combat this is by allowing people on our platform, on the DEX itself, to pay transaction fees in whatever asset that they are holding, assuming that asset is whitelisted as a transaction fee payment asset, right? So this basically means that you can bridge eventually down in the line, in the future, bridge whatever token you would like into the DEX itself, use that to perform your trade, plus use the same token to pay the transaction fees as well. So this basically breaks down any barriers for onboarding that you might face. So let's take a look at the features a little bit more in detail. There are some sections that I will present, and then I'll invite Rafael on stage as well, who worked on certain features too. So the first feature is liquidity bootstrapping pools. You can find the implementation in the following pull request. So if you are interested in seeing the code itself, please head over there, and we can discuss asynchronously as well. So why are LBP pools beneficial? The first important thing is that you get good price discovery. So thanks to the weighted LBP curve, if you want to launch a token using this method, it allows you to arrive at the most accurate market price during your token launch. Secondly, it allows for fair token distribution. So thanks to the automatically weighted adjusted price movements, more users can get their hands on tokens at various price points. So this results in a wider token distribution. So you will not have a ton of whales because more people will be able to get their hands on the token. And then also for the people launching their tokens through the LBP mechanism, it creates an opportunity for a low initial investment, thanks to being able to manipulate the weight initially at launch. And projects that launch their tokens with LBP don't need as much liquidity as they would need if they were starting to sell their token with these ZKI pools. So this again lowers the entry level barrier to being able to launch a token that will have sufficient liquidity behind it in the end. I will let Raphael talk about volume oracles next.
All right, thanks, Matej. So basically, volume oracles, the kind of the reason why we built this is like first to kind of showcase the possibilities of the tech stack, and then also for a feature that I will come to after that, our dynamic trade fees. So what are oracles in our setting? They are basically kind of some way to track some data that comes out of the continuing operation of the DEX itself. So in our case, that's the volume. The volume, most of you know it from like all the charts and the crypto analytics tools, is basically just the sum of all the assets that have been traded in a specific amount of time. And so the way we do this, we track it per block. So what we can do is for every pool that exists in the XYK DEX, we track the volume by just summing up all the transactions and the traded assets that have been traded in that pool. But not only that, we also track the net difference between the bought and the sold assets. And this basically, we call it that, I think, the net volume. Basically allows us to kind of keep track of in which direction the volume moved the price. So if that was like a positive movement, if more people bought than sold, or in the opposite case, then the price would obviously fall. So what can we do with those volume oracles? The first is some kind of advanced tokenomics or advanced mechanisms. And in our case, that's going to be used in the for the dynamic trade fees, but like also different other types of mechanisms can be built on top of that. And also worth mentioning is that not only volume can be tracked with these oracles, but also other things like, I don't know, number of users that traded with the pool, or yeah, the price, for example, stuff like that. And one of the most important things about those oracles is that they are provable. So we can make on-chain execution on top of them and not only have them on like, I don't know, some dashboards that are not provable. All right, so let's move on to the dynamic trade fees, and that is like one feature that was very important for us, because in most DEXs you can see extreme volatility to the up and to the downside, and the people that are most affected by that are the liquidity providers, because they are subject to impermanent loss, which means like the more the price moves, the more loss they or the more reduced downside they get. So one way to kind of mitigate that is to adjust the fees of the pools, which are like normally fees are implemented in a way that for every trade you pay, for example, like 2% of the trade size to the liquidity providers. But what we can do with dynamic fees, we can adjust them based on some data. And the way we do that is we use our volume oracles to adjust that fee based on the net volume. So that means that in the cases where the prices of any pool goes up or goes down very rapidly, we can say, hey, instead of 2% fees for your trade, the fee is going to be 4% because you will move the price additionally, and the price volatility is so high currently. And that way we can kind of reimburse the liquidity providers for their impermanent loss. And yeah, so basically the way we do that is for every trade that you make, we access our previously built volume oracles. We get the net volume. We adjust that by the pool size, and out of that we get something we call volatility. And then basically based on that, you can configure how big that volatility should affect the fees that you have to pay. or the developer can obviously configure that, but the user has to pay that. And yeah, and I think that's about it. I will give the mic back to Matej, who will talk about the multi-asset transaction fees.
Thank you, Rafael. Yeah, so the last feature from the second half of Core 3 that we wanted to build was the support for multi-asset transaction fee payment. Again, the pull request was always visible at the bottom, so you can find that in our GitHub as like proof of delivery. So let's talk about the feature in a little bit more detail. So why should we accept multiple assets for transaction fees? I mean, I've already covered it at the start, but let's talk about it again. So main reason, simplified user onboarding. Accepting various assets for transaction fee payments simplifies user onboarding, and it enables us or our users to bridge and swap with their single desired asset. So you don't need to have one asset to pay the fees and one asset to do the trading. You can just use one asset, which is much easier. Second reason might be diversification of protocol treasury. So there's pretty much two ways you could build this feature. One would be that whenever, so let's imagine the use case, right? So we have a DEX and we have an asset that we want our users to pay transaction fees in. Let's assume that asset is Mina. Now we have a user coming in who only has DAI. They don't have any Mina, right? But what would that mean? Like they wouldn't be able to make a transaction, right? They have no Mina to pay the transaction fees. So to be able to onboard these users, we will allow them to pay the fees in DAI. Now, what happens to the DAI and how do we even calculate the amount of DAI, right? So that you need to pay. So first you need to understand how do we even calculate the amount of Mina that you are paying for the transaction. So currently in the Berkeley model, and therefore also in the Kaupang DEX, the way we calculate the amount of tokens you have to pay for the transaction fees is by looking at the proving complexity of the work that needs to happen to prove your transaction. So there's multiple factors involved. We currently only use the complexity of the circuit as a parameter to calculate how much you're paying in fees. So once we calculate the complexity of the circuit that needs to be proven to include your transaction into the settlement for the DEX on the L1, I know I'm like basically fast forwarding a little bit, but let's come back to the fact that we have to calculate the amount of Mina I have to pay for the transaction fee, right? Now, how do we determine how much DAI the amount of Mina should be, right? So thankfully, we are on a DEX and we should have a pool between Mina and DAI. This essentially serves as an oracle, a price oracle on its own that allows us to implement the feature of paying the transaction fees in DAI. Because at any given time, when a transaction from the user arrives, the protocol can take a look at the XYK pool for the given token pair, deduct the spot price, and then do the conversion on the transaction fee amounts, and then deduct the amount of DAI that the user needs to pay for the transaction fee. And then the last step would be, where does this DAI go? So there's two ways to do this. Either you just do the conversion and then send the transaction fees to treasury in that other asset, in this case DAI. The second way to implement this feature is that you can do an atomic swap, right, at every user transaction in the pool itself, transfer the DAI to Mina and send the Mina to the protocol treasury to be collected as transaction fees. So I believe that was it in terms of the feature overview. Thank you for listening and stay tuned for our testnet release. If you have any questions, I would be happy to answer.
Kobe, please.
Hey guys, really exciting work. I'm wondering if on your roadmap or maybe as something like another team could take up.
Kobe, are you speaking? I think you're on mute, or I don't know. We can't hear you.
It's super silent, yeah. Or you can just type it in the chat and we can answer ad hoc. Mahmoud is asking how would slippage be handled in this case. I assume you're referring to the transaction fees. The first answer I can think of is that you wouldn't need to select like a transaction limit that wouldn't be equal to the actual amount that you should be getting out, because it's handled on the spot, right? So normally when you set transaction limits for ZKI trading, you do that because there will be other trades before you, quite possibly in the same block, and therefore the amount that you will get out will change, right? So therefore, in this case, since it happens ad hoc and atomically as part of the protocol, there will be effectively no slippage on top of the amount that will be calculated on the spot by the protocol. Rahul is asking, you could over collateralize by a little bit, then it becomes like a very small loan that always goes under. Not sure what that is referring to. Then somebody is asking, when will testnet release? That's a good question. As soon as I will know, I will let you know. Any other questions? Okay. Is your provable volume Oracle something that could be used for DEXs on other chains in the future? I can imagine it would be attractive to existing LPs to come to Kaupang. There can be VIPs from the start based on volume from other chains. I mean, we could do this, but then it would have to be the other way around. Like we would have to take a look at volume on other chains, which would have to be provable, and then kind of assign VIP status to LPs. I'm not sure what that would constitute. I mean, give them a better ratio when they provide liquidity and they get more LP tokens. I'm not sure if that would work in terms of the math. So we can certainly explore that. Then Mahmoud is asking, previewing token values, the transaction would take time due to proof generation, the value could change, and that was my concern about slippage. Yeah, so thankfully, since you're using BurtoKit or XYK in this case, you don't have to do any proof generation on the front end, you are just signing a transaction. Then the sequencer includes your signed transaction in a block. After ordering all the transactions in the mempool that are eligible to be included in the current block, and then creates proof of all of that execution. So, and the transaction hook, the transaction fees are implemented as something that we call transaction hooks, which is a protocol feature. And that happens atomically alongside with your actual transaction execution. So let's say that you are doing a transfer on the Kaupang. That would be a transfer runtime transaction to a runtime module called balances. The method would be called transfer. At the same time, when that method executes, the protocol transaction hook would run that handles the transaction fee payment, and it would all happen atomically together. So there wouldn't be any space for any nefarious activity in between. Rahul, you could okay. So, yeah, that was a response to Mahmoud's slippage question. Yeah, I'm not sure that's applicable, but okay, maybe I'm missing something. Any other questions?
All right, seems like now. And thanks again, Kaupang team, for the presentation and addressing the questions. Yeah, claps.
Thank you.
So we'll continue with ZK. Okay, Pete, if you're ready.